Alright, so today I want to be explaining surds as fast as possible. Now, these are the rules of surds that you're going to have to understand. Root A times by root A will be equal to A. Now, what is root? So let's say we get the root of 4. It's going to be the same two numbers that give us 4. So what are the two numbers that give us 4? That will be 2, right? Because 2 times 2 equals 4. So it literally just means two same numbers multiplied to give the answer of the root. Just leave it as that. And then we're gonna also another term that we need to know is rationalizing, which just means make the bottom denominator rational, which is divisible or just like an integer. An integer. So for example, a over root b, that's something that we kind of want. I'll show you in an example right here. This is a common type of question. Question 1 over root 2. This could come up in your paper, very common. So how would we do that? How would we turn this into an integer, like a real number, a rational number? What we do, we use this rule, the first rule. I'll label these rules real quick. Root A times by root A will just give the number back. So using this logic, root 2 times by root 2, this is going to be 2. We'll show that we times this by root 2. And remember, whatever's happened on the denominator, we do on the numerator. Question 2. 1 over 2 root 2. This is also a common one. Now, you'd probably say times this by 2 root 2. Now, that's not wrong, but what I do is times this still by root 2, because what that means, that is equal to 2 times by, because this literally just means times, as you can see here from rule 3. 2 times root 2 times root 2, which we know is 2, so that's just going to be 4. This is 2. 2 times 2 equals 4. So 4 over, we're going to also times this by root 2, times by root 2, which is also root 2. Now another third common type of question is, for example, maybe we have 1 plus root 2 over, I guess root 3, something like that. What you do here is times this by root 3, times this by root 3. Now we get a beautiful 3 at the bottom. And we also get this 1 plus root 2. Now we can expand the brackets, root 3 plus root 6 over 3. I don't think we can really do anything else, but yeah. Another common type of question, which goes harder than this, is 1 plus root 2, and then we'll do something like 3 root 2. Alright, let's make that 3 root 2 minus 1, and plus 1 for now. What we do here is times this by the opposite, times by root 3 minus 1. We just times this by the opposite. You see this? We just switch this with that, so we get an integer. We get like a normal number at the bottom. So 3 root plus 1 over 3 root minus 1. And then here, 3. And whatever we do to the bottom, we do also to the top. 3 plus 2. And then root 3 minus 1. And here we'll actually do the top first. Actually, we'll do the bottom first. Root 3 times by root 3, which is 3. Root 3 times by minus 1 is minus root 3. 1 times by root 3 is plus root 3. And 1 times by minus 1, which is minus 1. And then here, we do 1 times root 3, which is root 3. 1 times minus 1, which is minus 1. Root 2 times by root 6. And root 2 times by root 3, which is plus root 6. Root 2 times by minus 1, which is minus 2. Now, if we simplify that, we know these two are going to cancel out. This always happens. These two surds will always cancel out. You need to make sure that happens. And then we'll get 3 minus 1, which is 2. And then here, root 3 plus root 6, minus root 2 minus 1, which is a really, really weird answer, which is a really weird question, right? Because normally we just get like 1 root, but I didn't do this from the top of my head. But if you use the same logic, you'd be able to answer basically almost any surds question.